Welcome to this Maths Made Easy video on circle geometry. And what we're taking a look at first here is actually the equation of a circle. Now you may have investigated this in GCSE Maths, however at A-level Maths we're going to be taking a look at more complicated questions regarding circles and circle geometry. So to start with, we've got this example circle here. And we're concerned about two parts for this circle. We're concerned about the centre, denoted AB, and we're concerned about its length here, which is actually the radius, because it goes from the centre to a point on the circumference. And we can denote the equation of a circle simply as x minus a all squared plus y minus b all squared, and this is equal to r squared. And this corresponds to this circle that we've been given here. So how do we identify the centre AB here? Well, simply all we do is we take a look at this part here, this x minus a, and this y minus b to identify our centre. So this x minus a corresponds to our a value. Okay, so that corresponds to our a value here. And the b, the y coordinate, corresponds simply to our second part here, this y minus b. Okay, and notice as this is minus a, the centre is positive a, and same again here, this is y minus b. So in this term here, or this y coordinate here, it's simply positive b. Okay. We've also got r squared here. So if you want the radius, that's simply obtained by taking the square root of this r squared value here. Okay. So the centre is simply given as AB, and the radius is simply the square root of r squared, which gives us r in that case. So here as an example, let's just say we have this equation of a circle, x minus 3 all squared plus y plus 5 all squared, and this is equal to 16. What we want to identify here is the centre and the radius. And remember, taking a look at this equation here, corresponding to this circle, we can easily extend this now with our given equation. And in this case, the centre would simply be obtained by taking a look at this part here, x minus 3 all squared, and this part here of y plus 5 squared. Again, we take the opposite value, so as this is minus 3, our x coordinate for the centre will be positive 3, and as this part here, this y plus 5, this is positive, our y coordinate here will be minus here, it will be negative. So our centre is 3 minus 5, and what about the radius then? Well, the radius is simply obtained by taking the square root of r squared, and my r squared here is 16. So the radius is equal to the square root of r squared, which is 16, and the square root of 16 simply gives us 4 there. Now sometimes we may be given the equation of a circle in this form, x squared plus y squared minus 6x minus 4y minus 12 equals 0. And we may be asked to find the centre and the radius given this equation for the circle. So what we need to do here is take this equation and somehow get it into the form of x minus a squared plus y minus b all squared equals r squared. We need to get it into this form here. Once we can do that, we can easily identify the centre and radius. So taking this equation here, what do we need to do first? Well, what I'm going to do is I'm going to put the terms involving x together. I'm going to also put the terms involving y together, and we're also going to be left with this minus 12 at the very end. So getting this into the correct form first to work with, that's going to be x squared minus 6x. We've also got our y squared here, so we've got the x's together. Now we collect the y's together. So we've got y squared minus 4y. And in that case, all we simply got left here is the minus 12, and this is equal to 0. Now here, what we need to do is we need to think about this again in two parts. We've got two parts here, x minus a squared, and we've got this part here, y minus b all squared. So let's just change the pen colour here to make this nice and clear what we're actually doing. And we're considering this in two parts, one in terms of x, and my second part in terms of y, which we'll represent in blue. So here, let's consider the part in red first, the x squared minus 6x. What we're going to do is we're going to complete the square on the part in red. We're also then going to complete the part complete the square here on this part in blue, and then we're going to collect everything together, and what we should find at the very end is we have it in this form here, which is a nice easy form to identify the centre and radius. So completing the square first on this part in red here, well, that's simply going to give us x minus 3. We square this, and again we'd square this minus 3 here, which would give us positive 9, but we want the minus of this because we're completing the square, so that's minus 9. So that's the part in red here. These are equivalent. We've just completed the square on this part. We now need to repeat this on the part in blue here. So in this case, we're going to get plus y minus 2 all squared. We square this minus 2 again, which would give us positive 4, and again we take the minus of that, so that's minus 4. And simply what we've got left here is this minus 12, and this is all equal to 0. And all we simply need to do here now is collect everything together, which can be collected. So what we mean by that is this minus 9, minus 4, and minus 12. If we collect them together, what that actually gives us is minus 25. So in total what I've got here is x minus 3 squared plus y minus 2 squared minus 25 is equal to 0. And simply all I need to do here now is take this 25 across to this side to obtain it in this form then. And if we do that here, what we obtain is x minus 3 all squared plus y minus 2 all squared is equal to 25. And from here, we can easily identify the centre and radius. The centre is given by x minus a all squared plus y minus b all squared. So in that case, therefore, my centre is simply positive 3 for the x coordinate and positive 2 for the y coordinate. So it's 3, 2. So that's my centre there, and the radius is simply given by taking the square root here of r squared. So in that case, it's going to be the square root of 25, giving us 5 there. Okay, so therefore, that's our centre and radius for this given equation of x squared plus y squared minus 6x minus 4y minus 12 equals 0. And finally, we can take a look at circle theorems. Circle theorems are an extremely powerful tool when solving geometrical problems involving circles. The first circle theorem that we can use is the fact that the angle subtended by a semicircle is a right angle. You may want to take note of these circle theorems. So the second circle theorem here that we're going to use throughout when problem solving is the idea that the perpendicular from the centre to a chord is a bisector for the chord. And this is extremely important when we're taking a look at circumcircles, which you will also see later on if you're doing EdXL. And finally, my final circle theorem here is the idea that a tangent and a radius meet at a right angle. Again, this is extremely important, but you should have come across all three of these circle theorems at GCSE Maths. This concludes this Maths Made Easy video on circle geometry.